communications. The next section will be for Earth weather observation and prediction. Military reconnaissance experts, aided by powerful optical and radar telescopes, will observe every point on the globe as the space station makes its complete trip around the Earth every 2 hours. Next is the emergency hospital section. And then the astronomy division, where men will keep an eye on the rocket ship as it makes its trip around the moon. The rest of the space station will house calculating machines, maintenance facilities, air conditioning equipment, living quarters, and even a botanical and zoological laboratory. This entire space station will have to be prefabricated and tested on the ground. After dismantling, it will be transported in pieces up to the orbit. For the difficult job of reassembling the structure, we have provided a new type of spacesuit. Using gyros and 2 small rocket motors, the operator can tilt and move in any direction. Located outside will be 7 remotely controlled mechanical arms, each a specialized tool. By rotating himself within the spacesuit, the operator can use any of the arms for the variety of tasks in assembling the space station. When the day arrives for construction to begin, the thousands of parts for the space station will be transported to the orbit by our multi-stage rockets. We merely replace the winged passenger section with a simple cargo-carrying nose. These cargo ships will be unmanned. A passenger rocket, 1,075 miles above the Earth, will guide each of the 12 approaching cargo rockets to their rendezvous in the orbit. This ship, which circles the Earth every 2 hours, will be the command post until after the space station is finished. On the ground, the first of the cargo rockets is ready for takeoff. When the guide ship reaches the correct position in the orbit, the cargo rocket is fired. While its motors are firing, the cargo rocket is controlled by an automatic pilot, like a guided missile. Up in space, the blast-off is observed with the aid of optical instruments. In the guide ship, the navigator locks his tracking radar on the rising cargo rocket. At about 24 miles altitude, the first stage breaks away and the second stage motors fire. 2 minutes later, the cargo head blasts away from the second stage and continues firing until its speed reaches 18,468 miles per hour. Automatically, the motor cuts off. Now, with the aid of remote controls, the navigator rotates the rising cargo rocket so that when it arrives later in the orbit, it will line up with the guide ship. Here, at 1,075 miles up, follows the most precise maneuver of the entire operation. The motor of the cargo rocket is fired again until its speed and course exactly match that of the guide ship. Radar remote control will enable this maneuver to be performed with a high degree of accuracy. 56 minutes have now elapsed since takeoff. The cargo ship is floating in space, 2,000 feet ahead of the guide ship. 2 crew members make their way to the cargo head to begin the unloading operation. First, the motor and tanks are detached. Then 2 bottle-type construction suits are removed from the hull. When fitted in the airlock, each of these construction suits will receive an operator. The sections of the cargo ship are moved back to make way for other supply rockets soon to arrive. Construction of the space wheel now begins. The sides of the cargo nose are mechanically separated. Built-in tanks of compressed air inflate this large plastic inner section of the hub. Thin metal plates are immediately clamped on the outside to protect it from meteors. The first workday in space draws to a close. Every 24 hours, another cargo rocket will arrive in the orbit. When the airlock is attached, the pressurized hub section can be used as temporary quarters for eating and sleeping. Each succeeding load is carefully scheduled so that the parts of the station can be assembled in correct order. Nylon ropes prevent the parts from slowly drifting away. Next, the atomic reactor is installed. The wheel begins to take shape now as the three main spokes and rim sections are joined together. Condenser pipes are fitted next so that the atomic reactor may be put in operation. Even though there's no apparent motion, everything in the orbit is hurtling around the Earth at 16,000 miles per hour. The shell of the station is completed. Now comes the delicate task of installing instruments and the multitude of equipment inside. Finally, two small rocket motors on the rim, lasting for a few seconds, will set the wheel in permanent motion to revolve 3 times a minute. As life on the station settles down to routine, the large reflecting telescopes will begin their work. These giant eyes relay pictures to television screens inside the station. One telescope photographs the surface of the Earth. Another keeps a constant watch on the Earth's weather, while the third is trained on our next objective, the Moon. The primary purpose of the first moon trip will be to test the methods and equipment to be used on later voyages into deep space. It will be essentially a scouting trip around the moon, and no landing will be attempted. To understand the plan of the trip, let us use this model. Here is the Earth with the moon circling around it. Since the first half of the trip will take 5 days, we must aim the ship well ahead of the moon so that they both arrive at about the same point in space at the same time. Here we have a scale drawing of the Earth with the moon 240,000 miles away. This is the elliptical path which our rocket ship will follow, going out and coming back. For the rocket to leave the orbit of the space station, its speed will have to be increased by firing the rocket for a brief period of 10 minutes. The ship will then coast for 5 days. The Earth's gravity begins to slow the rocket down until 121 hours later, at a point within 60 miles of the moon's surface, it will begin to fall back toward the Earth. Gradually picking up speed, it will take another 5 days to coast back to the space station. This model will show you how our future moon rocket ship might be designed. It will be 53 feet in length, has no wings or tail surfaces, because it will be assembled and operated only in the vacuum of space. For the hull of the ship, we are adapting the cabin section of one of the Earth to Space Station passenger rockets. To the nose, we have added a small atomic reactor, which will drive a steam turbine and furnish electricity for the ship's instruments. This shield will protect the crew members from dangerous radiation. The ship's crew of 4 men will be placed 2 in the front and 2 back here. This is the directional radio radar antenna. Located underneath is the airlock for a spacesuit. The suit can be entered from inside the ship. Clustered around the rear of the ship are the 7 extra fuel tanks filled with hydrazine and nitric acid. All but the centrally located tank will be released when empty near the end of the return trip to cut down on dead weight. Even though we now have the theoretical knowledge to make a trip to the moon, it will be many years yet before our plans can fully materialize. However, let us imagine for a moment that the many problems have been solved and that after completing our space station, we are ready to begin our first voyage around the moon.
Ladies and gentlemen, through a worldwide network of radio and television, we are bringing you an on-the-spot account of the first expedition around the moon. Here at Space Station number 1, 1,000 miles above the Earth, the final preparations have all been made. Except for the time the rocket is on the other side of the moon, our radio and that of the station will be in constant communication with the ship during the 10-day voyage. As the moon ship stands by, the all-important pressurized spacesuit enters the rocket's airlock for the last time. During the trip, it'll be used only in the case of emergency. The captain is the last man to come aboard. He will direct the entire expedition from his position at the front of the ship. The navigator, with his specialized instruments, is responsible for plotting the unmarked path through space. The radio operator must maintain constant communication with the Earth on the space station. Finally, the rocket ship's motor and other mechanical functions will be the responsibility of the engineer. After final instrument check, the ship's crew lock themselves in position for the blastoff. Now, only minutes remain until firing time. The captain sets the automatic firing timer and reports to the space station.
RM1 to Station 1. Firing timer is engaged. We will begin power maneuver for departure in exactly 16 hours, 23 minutes, 47 seconds.
Roger, RM1, 16 hours, 23 minutes, 47 seconds, over.
Crew will secure and stand by for firing in 84 seconds. Acknowledge. Navigator, check. Radio okay. Engineer, check.